Learning target. I can identify asymptotes using limits, and I can graph rational functions. All right. Asymptotes with limits. What we've been doing has been successful with finding asymptotes, so I don't want to mess with it too much. So, if I want to find vertical asymptotes, what do? What are vertical asymptotes? How do I find vertical asymptotes? I find what? Well, it's x equals. So it's what value of x makes the function undefined, right? So what makes this function undefined? Okay, when the bottom is equal to 0, the denominator. That's x squared plus 1. So how can I make x squared plus 1 equal to 0? Are there any values of x I can put in there? 1. 1 squared is 1. 1 plus 1 is not 0. That would give me 2. Well, you don't notice there are none. 2. There are none. Sometimes there's no asymptotes. There are none. There is nothing that would make that equal to 0. Even if I put in a negative 1 and square it, well, negative 1 squared would be positive 1. So there are none there. All right? And our horizontal asymptote, well, what do? What do we do for a horizontal asymptote?
Biggest number for the top and the bottom.
Yeah, biggest term on the top and bottom. What's the biggest term on top? X squared. What's the biggest term on the bottom?
X squared.
Beautiful. And it's the limits as x approaches infinity, right? So what do I do here? I can, but what should I do first if I'm able to? Let me reduce that if I can. What's that reduced to? Is there an x for me to put a number in? Or for me to put infinity? No. Then the x of my horizontal asymptote is at y equals 1. Yeah, if you put it in infinity and end up with infinity over infinity, that's still 1. Now, what we do with limits here is we try to do the same thing for positive infinity and negative infinity. Why do you think we do positive and negative infinity? So, the limit as x approaches negative infinity, right? You're going to say it's going to reduce. It's going to reduce anyway. So we only have one asymptote. Well, why do we do that? Because on our axis, okay, x, as it approaches positive infinity, that's x going this way forever. Okay. I also want to check the other side. If I approach negative infinity in the x-axis, it's going this way forever. I really don't care with the horizontal asymptote what happens in the middle. I just want to know what's happening as it goes this way forever and this way. That's why I should check positive and negative infinity. A lot of the time, it's going to be the same answer. Okay? A lot of the time, it's going to be the same answer. So, why don't you guys take a minute and figure the vertical and horizontal asymptotes for this one? Okay. Right, so what do we have here? Vertical. What's my vertical asymptotes?
1.
Okay, so we're saying the denominator equals 0. You're telling me it's at x equals 1. There's one more.
Oh, yeah.
X equals negative 1. Because either one of those I put into here, when I square it, will become a positive 1. 1 minus 1 will give me my 0. That will make it undefined. That's what my vertical asymptotes are. Right? What about my horizontal asymptotes? What's the biggest term on top? 2. What's the biggest term on the bottom?
X squared.
X squared, which means the limit as x approaches positive and negative infinity. Can I reduce that any? No. So I'm going to have 2 over positive infinity, and I'm going to have 2 over negative infinity, aren't I? What will those approach? 0. As the bottom of a fraction gets bigger and bigger, the top stays the same, that actual value gets smaller. So both of these approach 0. So that's your horizontal asymptote. Let's check this out and see if it works. I have it set up right here. Let's graph this. It's a 5x5 window so you can see it a little bit better. Perfect. Good. Bam. What did we say? We said at positive and negative 1, there's negative 1. Those are certainly asymptotes right there. And at y equals 0, that's certainly an asymptote there. Good. Nailed it. Perfect. It's going to be right. Here we go. Graphing rational functions. We're going to graph these functions that are fractions. And it's not too bad. We're going to do it without a calculator and check it with a calculator. Now, we're going to start by doing our asymptotes. And we've already done these, so we're getting pretty good at them. What are my vertical asymptotes for the function x cubed over x squared minus 9? How do I find vertical asymptotes? Yeah, well, the bottom is equal to 0. So x squared minus 9 equals 0 when x is what?
3.
3. What else?
-3.
Yeah, positive or negative 3. Those are the only two values that will make the denominator 0, therefore there's asymptotes. Okay? What about our horizontal asymptote? I'm going to keep what? X cubed is the biggest term on top over x squared. And what will that reduce to? It does. You can cancel x's.
Oh, you need x.
Well, you x the first, right? That's it. Well, you can technically say over 1. And don't I want that as a limit as x approaches positive and negative infinity? Yeah, that means it'll go on forever. Therefore, that'd be positive infinity over 1 and negative infinity over 1. Right? And if that's the case, we would say there are, it goes forever. It goes forever. So there are none. Some answers would accept positive infinity or negative infinity, but you can say that there's no asymptotes, there's no horizontal asymptotes. That means it'll go up and down forever, and there'll be nothing limiting it. All right, I'm going to wait for this box. There's one more piece I'm going to show you. X-intercepts. Does anyone remember how to find the x-intercepts? For example, the x-intercept, if something crosses here at negative 4, what's the coordinate there? It's negative 4 comma what? 0. So it's wherever y is equal to 0, isn't it? So I take my function. Hold on. I take my function, which equals y, because isn't f of x the same as our y? And I just put a 0 for f of x. Okay, I just make my y value 0. So in this case, if it's a fraction, how does a fraction equal 0? That's not positive or negative 3, that would make it undefined. How is a fraction equal to 0? What's the one thing you know that makes a fraction equal to 0? Yeah. Yeah, if the numerator is 0. If the denominator is 0, it's undefined. If the numerator is 0, 0 over 5 is 0. 0 over 12 is 0. So as long as the top is 0, then the whole thing equals 0. So we just got to figure out what value of x makes x cubed, into a 0. And what is that? What do I cube? And it'll be 0. 0. 0 cubed is 0. Therefore, the x-intercept is at x equals 0. All right? That's all you have. So far. Vertical asymptotes at x is positive 3, x is negative 3. We have no horizontal asymptotes. It is going to cross the x-axis at x equals 0. What about the y-intercepts? How can we find the y-intercepts? Let's flip this. The y-intercept would cross the y-axis, wouldn't it? So, if this is 3 on the y, the coordinate is 0, 3, isn't it? So that's when I need my x's to be 0. So for my y-intercept, I still have x cubed over x squared minus 9 equals my f of x. Well, I want to know, what is this value when my x's are 0? So it's 0 over 0 minus 9, which is 0 over negative 9, which is 0. 0. That's my y-intercept. So the thing to remember here are to find my x-intercept, I make my y equal to 0 and solve, right? Right? To find my y-intercepts, I make my x equal to 0 and solve. That's the note to keep. That's the note you want. If you forget it, that's how you do it. All right. So we've got. Let's take a look at this. And let's kind of sketch this thing right here as we go. We have vertical asymptotes at x equals positive -3. Here's 3. Here's -3. And I have this asymptote comes down here. We have no horizontal asymptotes. We have an x and a y-intercept are both at 0 at the origin. I will graph this in blue. It's right here. Right, but there's one more thing that we can find. Asymptotes aren't always vertical and horizontal. Sometimes they slant. They slant. All right? So, slant asymptotes. To find a slant asymptote, all I do is divide the actual problem out. We have x cubed over x squared minus 9, right? When I divide, my asymptote is the quotient. Without the remainder. I don't care about the remainder. I just want the actual quotient. I want the number without the remainder. So I'm going to divide these. Okay? I've got x squared minus 9 going into x cubed. Can I use synthetic division? No, this has to be linear. This one has to be linear. That's like a 1x plus, so I can't. So I've got to use long division. You know what? And it's not as bad as it looks right now. I'm missing a term here, aren't I? What am I missing here? The x in the middle, right? So it's x squared plus 0x minus 9. Okay? The x is going to go into, what am I missing here?
Oh, 0x squared.
Yeah, I have 0x squareds, I have 0x's, and I have 0 as my number without an x. This really is only one thing. It looks like it's going to be tremendously long and difficult, but it's really only one step. Now, I know we've kind of gotten used to synthetic division as niceties, but who can remember long division? How do I do this? How many terms do I have on the outside?
3.
There's 3, so I always look at 3 terms on the inside, right? And how do I make x squared? I got to make it into the first term here, x cubed. I multiply by x. So if I multiply by x, well, my x terms are right here, so that's why I'm going to look at x. And then I'm going to multiply my x into here, 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 and I end up with x times x squared is x cubed. X times 0x, well, now I still have 0, and it's x squared, right? X times a minus 9 is minus 9x. And I subtract. Well, keep change. Plus, minus, plus. These cancel. There are no x squareds. And I have 9x. And I bring down this plus 0. Now, is there anything I can multiply my x squared by to make it into an x? There is. So guess what? You're done. That's the remainder. The remainder, 9x. So what did I say my slant asymptote was?
X.
Yeah, it's the quotient without the remainder, so it's x. So my slant asymptote is y equals x. That's my slant asymptote. Right there. So I'm going to now put that on my graph. And we know that is some sort of diagonal line. That's it, y equals x. Now, if you want, because it's like, well, how am I going to tell which way, where the graph goes or whatever? You can pick a random point. If I pick the number 1 and put a 1 in for my x's, that would be 1 over what? 1 minus 9 is 8. It'd be negative. Wouldn't it be a negative number? 1 over negative 8 is negative 1/8. So at 1, it comes down here. And if you go further, it's going to come down here. You'll see. So this kind of goes down like this. This goes up like this. And if you test some of these numbers on the far left and far right, you're going to kind of see it kind of goes like this. And your asymptotes will give you a guide as to how to write that. All right? Not sure. See if that has any sort of accuracy what we get.
Weird.
It is weird, isn't it? But we have x cubed over x squared minus 9. Now we'll go to a standard 10 by 10. Look at that.
It's weird. It looks like x cubed, but it doesn't touch.
Yeah, it's crazy. I mean, that's pretty much what we added if we draw our asymptotes.
And then it looks like 1 minus x, 1 over x. But it doesn't touch.
There you go. And there's our 1 intercept. The y is pretty spot on. Pretty crazy. Y does. Now that we have this, we have 1 left. Why don't you guys try one on your own? And then we'll go over it afterwards. Here we go. What's the vertical asymptote? Yeah, x equals -2. That's right where the fraction is undefined. The denominator is equal to 0. What about the horizontal asymptote? There are none. There are none, because if I keep the top and bottom biggest terms, I get x squared over x, which is x, and I plug in positive negative infinity. There you go, so there's none. Slant asymptotes, what do we do there? Divide, so we need synthetic division. 2 is going into, don't forget, it's a 1, right?
Yeah.
1,
-2, 3.
and then, how does that work? Drop the 1?
Yeah.
1 times 2 is?
2.
And I do what?
So
I get 0. You got it? 2. -8, and I subtract. Yeah. See, so we're something that same answer.
Yeah, oh.
Yeah, that's person, same chair, same spot. The code. There you go. That's your remainder. Which means this is technically 0x's. This is 1x, right? So y equals x minus 4. That's my slant asymptote right there on that line. Now, the y-intercepts seem to be easier than the x-intercepts, don't they? Let's get these up here. Okay, we have our x-intercepts, and we have our y-intercepts. Our y-intercepts, don't forget, we just make our x is equal to 0 and solve, right? Or simplify. So, I'm going to have 0 squared minus 2 times 0 plus 3 all over 0 plus 2. Yeah, you get 3 over 2. That's my y-intercept. Now, what about my x-intercept? That means I got to set y equal to 0 and solve, right? Which means I just need that fraction to equal 0, which is just the top. So if I say 0 equals x squared minus 2x plus 3, I can't factor that. If I did a quadratic equation, that would take some time. How else can I solve? I can solve it graphically, can I? Can I graph it and see where it touches the x-axis? That's my answer. Let's do that. You guys do that, I'll do that here. We'll see if we come up with the same thing. X squared minus 2x plus 3. I'm going to go to standard 6. What do you guys come up with? It is a view, text LCD. It is a parabola. So what are the answers? It doesn't touch at all, does it? So there are no solutions, which means if there are no places If there are no places where this equals 0, are there any x-intercepts? No, there are none. There are none. Because if you were to try and factor that using quadratic equation, you get imaginary numbers. Complexes are behind it. All right? So let's put all this in a graph and see what happens. Okay? Here they're in the graph. Okay? Put this over here. I don't know why there's 2 of these, but we'll get rid of one of them. Box. There we go. So, first things first. Vertical asymptote at x is minus 2. Here's negative 2. There's my vertical asymptote. Okay? There's no horizontal asymptote, but there's a slant asymptote. Here. Well, at the line.
Oh, yeah.
So I come down to minus 4. 1, 2, 3, 4, and I put a dot there. That's at minus 4. And then my slope is a 1, so it's up 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. Sorry, these lines aren't working. Here, up 1 over 1. It looks something like this. Okay? Now. Good. So, let's see the accuracy. Now, I have a Y-intercept at 1.5, which is 3 over 2. So if I go to 1.5, it's right about there. Does it touch the x-axis? Which means if it doesn't touch the x-axis, I can't go like this, can I? And anyways, there's asymptotes there. So I can't do that. So it's probably going to be something where it kind of comes out, it doesn't touch the x-axis, does it?
It gets close.
Yeah, it gets close. It probably does that.
It does.
I can't do anything over here because I can't go like this because it doesn't touch the x-axis, does it? And likewise, I can't do anything over here because it doesn't touch the x-axis, does it? I mean, let's check out the graph and see what we got. Y equals clear. What is the fraction?
X squared minus 2x plus 3.
X squared minus 2x plus 3. All over?
X plus 6.
X plus 2. Let's graph this. Bam! Wow, look at us go. Look at us go. It's pretty darn good. Look at us go. Sorry.